Let's continue by marking the angles in radians on the unit circle. And we're going to do this similarly to how we did the degree marking by thinking about a full rotation as 2 pi radians and then taking fractions thereof. So if I start my angle in standard position, which is what all of these are marked as, on the positive x-axis and go all the way around, I know that is 2 pi radians. So I'm going to put that here. And I know if I start on the positive x-axis but don't go anywhere, then I'm going to have just 0 radians. So if all the way around is 2 pi, then just halfway around is just a pi radians. And we don't write radians every time, but we can assume without a degree marker and we're talking about an angle that we're indicating that we're measuring in radians. Okay, so we've got 0 pi and 2 pi marked here. And now we can also mark, let's see, if here is to 2, sorry, if starting at the positive x-axis and then going to the negative x-axis is pi, then halfway is pi divided by 2. And pi divided by 2 we just think of as pi over 2. So that gives us that angle there. Maybe I'll write it in green to be consistent with my other markings. All right, so pi over 2 radians there. So let's mark all of our kind of pi over 2 marks. So if we start at 0, then we have 1 pi over 2 here. Then I'd have 2 pi over 2, but I see 2 pi over 2 is just pi. Then I get down here to 3 pi's over 2. So I'll write that in. And then 4 pi over 2 to 2 pi. So I'm just saying this would be now at 4 pi over 2, because that's how many pi over 2 kind of chunks that we've done, right? But we see that's just 2 pi. Okay, so we'll see a lot of that where we go, oh, we already have that angle, but if we simplify it, we just get that back. So we can kind of use that to double check. All right, so now let's look at halfway between 0 and pi over 2. So we say, all right, well, then what would this be? And now we could certainly use the fact that this is already established to be 45 degrees and say we could convert degrees into radians from there. But I like just working in radians because we can think of this just in terms of the sizes of the angle. So if this is pi over 2, this is half of that. So what would that look like? Well, pi over 2, half of that is the same as multiplying by 1/2, right? I can take pi over 2 and divide it by 2. That looks a little funny sometimes. So I could do pi over 2 times 1/2. That's just pi over 4. Okay, so what I've just then determined is that angles of this size here are pi over 4. So then anytime I add on another angle of that size, I'm just adding on another pi over 4. So let's see, this would be 0, then pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. So I'm only missing one of those. This is, again, 3 pi over 4. But notice that all of these are listed in their simplified form. So I just said, well, this was 4 pi over 4, but we'd rather just call that pi. It's a little bit easier. Okay, so let's keep going with that same kind of angle size. So we said pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. Okay, we don't have that one yet, so let's put that one in. 5 pi over 4. 6 pi over 4. This one would be 7 pi over 4. Ooh, we're missing that one. All right, great. 7 pi over 4. And then all the way back to us would be 8 pi over 4, but that's just 2 pi. So great. All right, let's keep going. So similar to how we did with degrees, if I just think of this top half as being an angle of pi, right? So this is an angle of pi. These angles here are a third of that. Well, that's just pi over 3. So what we're saying is that since an angle of this shape, 3 of them fit within pi, that each one of them would be pi over 3 large. So here's pi over 3. Well, I have 2 of them by the time I get to this marking here. So this would be 2 pi over 3. Okay, then 3 pi over 3, but we say, wait a minute, we already have that labeled as pi, so we can just skip that one. All right, what's the next angle of that size? I'm going to have 4 pi over 3 here, and I'm going to have 5 pi over 3 here. Okay, great. Okay. And then once I'm back, I have 6 pi over 3 when I'm back to a full rotation, but I know that's already just 2 pi. Okay, not very many left. Let's keep going. We have this as pi over 2. This size is pi over 2. And, and so we can think of it this way. We could say this is pi over 2. Well, we want to know this size, right? Because we haven't labeled it yet. So if this is pi over 2 and there are 3 chunks within pi over 2, how big is that chunk? Well, then what we're really asking is, here's pi over 2. What's a third of that? Well, 1/3 of something means multiplication. So this is just pi over 6. All right. So this size here is pi over 6. So let's see if that works. So this is pi over 6, 2 pi over 6. Does that work? Let's make sure. 2 pi over 6. Ah, that's just pi over 3. Okay, good. Let's keep going then. Pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. Ah, there's a missing one. 5 pi over 6. Good. 6 pi over 6, 7 pi over 6. We need that one. I'm down here. Let's see. 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. There we made it over here to our missing one. 11 pi over 6. And then a full rotation back would give me back to 12 pi over 6, which is just 2 pi. So now we have completely filled in the radian measures of these angles that are marked on the unit circle.